Good morning everybody and welcome to our course on Introduction to Mechanical Micromachining Processes. In the last class we have seen the classification of different processes and then we have compared the two different domain of the micromachining or the microfabrication processes. One is related to micro electromechanical system and another one is our course related to the mechanical micromachining processes. And we have seen that there are a lot of differences between the processes or the two domain of the processes. Now, there is one more domain which is related to the ultra precision machining. So, that ultra precision machining is also considered as a one type of micro manufacturing processes or micro machining processes, and where we also do some type of processing in terms of the micro material remolded. So, now let us discuss about the differences between the micro mechanical machining processes and the ultra precision machining processes. So, these are the things which we have discussed in the last class. What are the difference between the MEMS processes and the micro mechanical machining processes. Now, coming to the mechanical micro machining processes versus ultra precision machining processes. So, what are these ultra precision machining processes? If you see this particular diagram, we have two distinctions: micro mechanical processes. So, this particular thing is here and this ultra precision part that is here. So, this is the ultra precision manufacturing and this is what we are talking is the micro manufacturing processes. So, where is the difference? So, difference is in the size. So, this is the domain. So, now if you see the size of the component for this is very large in this case. Apart from that, not only large, but also you can get a very high relative accuracy in the ultra precision manufacturing. But that is not the case of the micro mechanical machining processes, where the size of the component is 1 millimeter or less than 1 millimeter and the relative accuracy is also less compared to the ultra precision machining or ultra precision manufacturing. So, let us see that what are these processes. So, what are the processes? In these processes we know all the processes like milling process, turning process, drilling process, and in this particular this is the example that this is the shaft fabricated by the mechanical turning processes, and you can see the dimension is a less than 50 or 20 micron of the dimension, and it is called high aspect ratio structure. Now, what is high aspect ratio structure? High aspect ratio means it is a L by D. So, here length is very high and the diameter is very small. So, here you can say that length is very large, but if you see the diameter is very small. So, that is in terms of the rod, but same thing can be applicable for the hole also. So, now if you see this is the depth of the hole and this is the diameter of the hole. So, in that case also it is called high aspect ratio hole and here it is called high aspect ratio structure. So, that is the difference. Now, what is the process available? Here there are two processes available and one is called the diamond turning operation and another one is called the fly cutting. We will cover this procedure in more detail when we cover this particular topic. It is called ultra precision machining, but for present slide let us see that what is the diamond turning. So, diamond turning operation, there are two words, one is the diamond and another one is the turning operation. So, diamond is applicable for the tool and the turning is the process which we are using for that. So, here we use the diamond as a cutting tool. Diamond is a cutting tool and the process is turning operation. Right. So, now you know that how this size is measured. So, now see the size is in terms of meter, and now you can see the considering the size of this component, this is the cutting tool and this is the component. If you see this particular size, its size is in a meter scale, consider approximately 1 meter, right, and whatever roughness or the tolerance you are getting, that tolerance is very tight. That means, you can get the surface roughness in terms of nanometer. Surface roughness less than 20 nanometer, and this is about diamond turning. Now, what is the fly cutting operation? Now, fly cutting, now let us see here that this is the component and this is a chuck, and then you are doing a facing operation. This is the cutting tool and it is moving in this direction, and then it will do machining at this particular face. So, this is called the facing operation. So, we are using a cutting tool like this, but now suppose you want to create one cavity here. Now, your surface is something like this, correct. Now, there are two ways of doing this thing, that you put this tool inside and then create a one cavity like that, then you move this along the curvature. There is another way, that you mount this tool like this. Now, this is the cavity, this is what the same cavity suppose you want to make. So, this is the features of this cavity, and if you see the cross section of this, you will get something like this surface, right. And now, this is the single point cutting tool, same as what we are using here, but here difference between these two is that this will be in rotation. So, this is the spindle on which it will rotate in this direction continuously, and then it will penetrate inside it. So, now this is the way it is happening here. So, this is the cutting tool and this is the spindle, and then this spindle will rotate in this direction. So, it will rotate and it will remove the material continuously in this direction. In other way, here what you have to do, that suppose is this is the same feature here and this is the same cutting tool, then what you have to do, you have to move this cutting tool in this direction to cut the material. So, this is called the diamond turning operation and this is called the fly cutting operation. Here the advantage is that you can get the required features here, because many times what happens, suppose you want to create some type of features here, that is some type of slot or some type of small features here, that is possible by fly cutting operation. We will see everything in detail in the mic. So, right now difference is there, the here tool can translate only in the diamond turning operation, but here tool can rotate at a high RPM as well as it can move in this direction. So, this is the fourth axis. So, this will rotate and this will move up and down. So, you can get the required cavity machine very easily in this case. Now, so what are the different tools we can use, because we know this micromechanical machining very easily. So, there are different type of cutting tools available, coated, uncoated, and there are different materials also. So, this is called high speed steel. This is called tungsten carbide. This is called cubic boron nitride. And diamond is well known. So, we do some type of coating also to increase the tool life of these particular cutting tools, and so that you can use the same tool for a longer period of time. and these are the cutting tools available. Now, if you see, this is the end mill cutter, but only thing the dimensions are in the micron size. So, this is the end mill cutter, the shank diameter is 4 millimeter, and this is magnified, and you can see here it is a 40 micron is the diameter of the cutting tool, and this is the drill available. So, here also you can do drilling operation. Readily available tool is 100 micron drilling drill bit is available right now with a very reasonable price. And here what are the tools? The tool material is natural diamond that we have seen in the last slide, that is why it is called the diamond turning operation. But here the whole tool is not made of diamond, because remaining part here you are not utilizing for any type of machining. So, here you can see that only a small tip of a diamond is soldered with the surface, and then this particular bit is indexed, or it will be held with the particular tool holder. So, once you use this particular thing, then after machining, or once this tool is worn out, then you put one under solder, or you can use another tool. So, here the part or the size or the cutting tool geometry is very small in this case, and that is here you can see that very large amount of part is available for machining, or the same material is available, because diamonds are very costly and you are not utilizing the whole surface of the cutting tool or indexing tool for a machining. So, it is better to restrict ourselves where we actually do the contact with the workpiece surface. So, these are the different natural diamond tools for machining under ultra precision machining or the diamond turning operation. What are the component size? Here we have seen in that graph between the component size to the precision parts. So, here it is a 1 micron to the 1000 micron, that is up to the 1 millimeter, and these are the different component. You can see that many of them are fabricated by the turning operation, many of them are for milling operation, and some of them you can do drilling also for specimen of the component, something like this. And here it start with the 1 millimeter to very large. Now, most of the application of this diamond turning or the ultra precision machining is the fabrication of mirrors and the lenses. Now, if you see, these are all highly polished, and you can even see the reflection also of this. So, roughness is extremely small, as well as the tolerance are very high in this case. And this is a small component. Here these are the very small lenses available. Even you can fabricate the intraocular lenses also by diamond turning machine. And here this is under operation or the under turning operation by diamond turning operation, where the size of the component is very large, and we can consider it in a meter scale also. So, here the dimension range is very large, from 1 millimeter it can go up to meter size also, even more than meter, but here the size of the components are very small, because our objective is to machine this component, but at a lower precision level or the lower tolerance level. Relative accuracy, that we have seen in earlier case, that the from MEMS to the micromechanical machining, the MEMS has the worst relative accuracy, because you will not get another chance of doing some type of correction by, that means by grinding or lapping or some other finishing processes, you cannot reduce the size, because the size of the component is very small, and it cannot bear large amount of forces during machining. But here it is possible to do little bit of machining, but it is even more tight in this case, because the size of the component is very large. So, you have a chance of reducing the surface roughness or the tolerance level to a one more digit down to the required dimension. So, here whatever it is telling, suppose you want to make a diameter of 20 micron, 20 millimeter, then you can go up to 20.601. So, up to that much precision is possible in the diamond turning operation, that is the advantage, but another problem that you cannot do machining at a micro scale, that is in terms of component size. Right. So, same graph is here. So, our particular location of this part is here, and you can see the tolerance level or the relative tolerances are here, and this particular thing is little bit expanded, but here you can see that it can go more than 10 raised to minus 6 also in this case, but here the range is this much only. So, that is the advantage of going with the ultra precision. If your requirement is with a high relative accuracy, you can go with this, but the dimension of the part is also very large. You cannot do machining with a very small component, but here you have this part. So, both processes have their particular domain of applications, where one process is useful, another is not. In other particular domain, this particular process is useful, but this one is not. So, that you have to select the process depending on the requirement and the accuracy. Now, surface finish requirement. Now, we know that once you complete the component machine by the micro machining process, by this particular process, you do not have chance to reduce the surface roughness. No possibility reducing surface roughness, rather we can write something that less, because if the dimension is very large, suppose consider it is a 900 micron or something, then you can do little polishing by a gentle polishing processes. So, let us write is a less possibilities, reducing the surface roughness of micro component. Because now you can see this particular feature, now it is a milled component. Now, where it is milling is done. Now, this is the milling is done at this location. Now, this is the top surface, this is the side surface. Now, this side surface is written here and top surface is written here, and this is the slot it is cutting. So, this particular surface is this one. And this is the edge of this part. So, now you can see that how this thing is visible. So, now this is the vertical surface, vertical wall, and this is the bottom face. Right. And now you can see there are many things here. First thing is the this type of things. So, these are called burrs, that is already written here. So, these are the burr, and if you see the surface also, now surface is also not smooth. Here you can see there are lot of debris or many things are there. Burrs are located on the top also. Some debris are also available. Some unremoved material which are loosely bonded with the surface, that is also available. Now, if you use this particular part for the later application, it is difficult to use it, because there are lot of joint loose materials available that will create problem in assembly or the final operation. So, what we have to do that if the dimension is very large, now if you see it is a 100 micron. So, this particular dimension is probably 100 micron by 100 micron, and this is open, that means you can actually see by the microscope, it is not something inside the component. So, if you do some gentle polishing operation, there are many advanced polishing operation available which can do some type of polishing. So, how to remove these burrs? So, it is removal of burrs by gentle polishing processes. Right. So, if dimension is very large and you can actually access that particular feature when you machine it, then there is a chance of doing that thing. But suppose you have drilled one hole, and after drilling, suppose you want to create, if you want to do some type of removal of the material or dimensional clarity inside the hole, then it is difficult, because you cannot enter inside something like a rimming tool or some type of other honing tool or something like that. Is difficult to access that particular hole. So, these are some of the way you can do polishing or some type of irregularity removal, but that depends on where those features are located on the surface. Now, coming to the surface of finishing in the precision, because now here surface is very large and the diamond is the very stable component, because here we are using diamond for fabrication of the non-ferrous materials. So, it can retain its geometry for a longer time as well as sharpness and the other features of the cutting tool. And that is the reason that you can get a very fine polished surfaces, and many times you even do not need any type of post polishing operation, because many applications need surface roughness around 20 nanometer or 10 nanometer. You can directly use this component for the final application. But again, we know that diamond turning is a turning operation. So, ultimately it also creates some turning marks. So, those turning marks can be reduced or can be eliminated in the final finishing operations that is performed by the, again this is gentle polishing processes. We will discuss some of the processes later when the course will continue. So, here these are the two different ways to distinguish between the roughness. Roughness is very large here comparatively, but it is very small here because components are very large and you have provision of polishing of this component further in the process. Now, where these micromechanical processes are standing in between the other processes. Now, this is one other comparison. Now, this comparison is with respect to the scale of the component, this is the accuracy. We have seen earlier also, but here this is giving a overall idea about this thing. So, if you see the nanoscale, actually nanoscale mostly it is atomic and material science, where we talk about the grain size and the dislocation density inside the material and so what are the features within the grain. So, and some of the processes we have seen, it is called NEMS, nano electromechanical systems. Now, if you go down to the micron size, then between the nanometer and micrometer we are working with the MEMS product. So, its dimensions are obviously smaller than the feature size which we can create by micromechanical machining. Then comes something between the millimeter to the micrometer size. So, here we are working with the micromechanical machining. Then when the part size is very large, from 1 millimeter to the meter scale, then we have conventional machining processes and the ultra precision machining processes. Now, coming to the Z scale. So, these are the different zone of the precision, high precision and the ultra precision part. Now, if you consider conventional machining processes and ultra precision machining processes, these two are combined here because both the dimensions are almost same. So, you can have a very large variation in the precision zone, accuracy zone, that you can create a very less precise component also by normal CNC cutting, milling operation or the turning operation, and if you want very fine features, then you can go with the diamond turning operation. So, how these things are important here. Now, if you see, if this particular thing is not available, suppose micromechanical machining processes are not available, then we are missing something between the few of millimeter to few of micron, because this is the domain of the conventional and the ultra precision machining, this is the domain of the mechanical electromechanical system. So, to bridge this particular thing, we need something which can fulfill our requirement between the mesoscale to microscale. So, that is the reason that we are more interested in fabrication of the component by mechanical micro machining, and it is bridging the gap between this particular domain, because one way it is a lithographic based process is available, another way we have conventional machining process available. These are very costly processes, here it is a reasonable cost, but problem is that you are not getting the required size neither in this MEMS product nor in the conventional machining process. So, it is very useful to bridge this particular gap between the MEMS and the processing. So, you can get the functional components. Complex microstructures on the variety of material interfacing and functional shapes can be produced by the mechanical micro machining processes, because when you see the complexity of the structure, Only possibility is that you do this same operation at a macro scale or it is bigger size. But if you go on the upper side of this dimension, that means on the smaller side of the dimension, complex structure cannot be fabricated, because these processes are unable to fabricate the z dimension at a larger stage. So, that is the problem of this MEMS product or some other components. Now, how these things important? Now, if you see a one operator who is operating a macro machine or the conventional machine, can the same person can operate the micro machine or not? So, there are different aspects of doing this thing, because operator gets some knowledge or expertise when you operate the machine at a macro scale. Suppose one operator is operating a machine for a many years. So, now he has some intuition that if some particular noise is coming out of the machine, he understands that this is what is probably happening there. So, he can control the machine very easily, because that is by some type of noise judgment, because he does not know actually what is happening, but because of the large experience he can actually operate the things very easily in this case. So, that is different. So, but problem here in micro mechanical machining, that those things will not help to this particular part. Why not happening? Let us see that thing here. So, machining skill has a different meaning in the micro domain. How that means? The skill based on human hands and human sense cannot assist the process the way they do in the macro region, because we know that how to operate the machine, because everything is visible, all the things are very clear to our mind, but that thing is different in the micro domain. Now, see, if this is the operation, we know the how chips are moving, tool is in contact with the surface, that also we know. If tool is broken, that is also visible. But when you go with this particular part, it is very difficult to find that how things are going on. So, here there are two different ways. Even experienced person is also fail to make the judgment at the micro scale. So, what are those two different type of things, that how operator knowledge is not making any help or not making any sense in the micro domain, or he has to develop some extra knowledge about the process by trial and error, that we will see in the next class. Thank you very much.